All right, so we have 3 undefined terms in geometry. Put a star next to it. The first undefined term is called a point. And yes, do you know how to spell it? Do we all know how to spell point? Yes. Good. Also, do you know how to spell line? Can we all spell line? Yes, the next one is going to be very difficult. Plane. The airplane, not the other plane. Make sure you know how to spell that as well. All right? Now, here's the idea. I think about a plane, and plane could be any field, right? Plane goes on forever. It could be any field. Some of you guys might see a rectangle as a plane. I see a rectangle. Some of you guys might see a triangle, which is fine. Any shape works. So let's say you forget the 3 undefined terms. There's a way to kind of remember. Imagine making a plane. You start with the point. Is that right? To make my plane, the rectangle, I am going to make 4 lines. And boom, I made a plane. So if you get stuck and I ask you what are the 3 undefined terms, and you go, well, for me to make a box, I put a dot, I make my line, and I made a plane. Point, line, and plane. Could we all remember that? Yes. Okay, so what is the first undefined term? Point. Spell it, right? Make sure you know how to spell it, I mean. What's the second undefined term? Line. And the last one? Plane. What kind of plane, though? More like an airplane. Good? Has to be in that order. Any questions on that? You're welcome. Okay, let's talk about what it looks like in a drawing versus if it were to be in a textbook. Point is a dot. And when you make any dots in geometry, we always name them. Point A. If this were to be in a sentence, it'll just say from A to B. Just A. Line has arrows on both ends. And we need 2 points to make a line. And again, when you're drawing anything, you always name the points. So in a sentence, it'll look like this. It'll say AB. Oh, that's AB, by the way. With the line symbolic notation above it. Could I reverse that to BA as well? Yeah, as long as you have that line symbolic notation above it. The symbol above is very important. Now, another way geometry textbooks might also denote the line, they might just give you an italicized, lowercase letter on the outside. And in that case, I'll just say the L. So you can always name it with the point, or in general, name it as with the point on the outside, or the name on the outside. For plane, again, I think of a rectangle. You could think of it in any shape you want. But then I want to kind of make it 3D-like. What shape would that make? Not almost 3D-like, but I see more like a plane in the shape of a rhombus or a parallelogram. Does it have to be that? No. You can leave it as a rectangle if you want. For a plane, you have to use capital letter to denote the whole thing. So I'm going to call this one plane M. And I'm not good with cursive, so I just put a swing at the end. And if you put a swing at the end, I'm good with it. Now let's use those definitions or those words to make our definition. We have something called collinear. What does the word co mean? Co. Together, okay? So if I tell you we have a line, that means we have points that lie on the same line. Is my handwriting okay so far? Not too bad? No comment? Okay. Thanks. So let's make a line. You can make it horizontal, diagonal, vertical, doesn't matter. At minimum, how many points do I need to make a line? 2. Very good. Does that mean I have to only have 2 points? No. You can have a 3rd, 4th, 5th, doesn't matter. But we have to always name them, A, B, and C. So since I gave you collinear, I want you to define coplanar with a partner. Go. Talk to your neighbor. Can we mimic the definition from above? What can we say, Caroline?
Oh, that was not what I was answering. I was asking like what a plane is, because I'm confused.
Plane is like a field, a flat surface. So our floor right now is our plane. Your desk right now that you're writing on is also your plane. Good? Okay? So then it'll be points that lie on the, lie on the same plane. So then I'm going to kind of model something. How many points do you think I'm going to need to make a plane? Do I need 1, 2, 3, 4, 5, 6? What do you think?
3.
Okay, hold it up. How many say 3? Very good. You don't need me. Okay, I'm going to kind of model this for you. If I have a point and I have this plane and I want this plane to guarantee be on it, it's going to wobble in every direction, correct? But if I take 2 points and then I put it up, it's going to swing left and right, correct? But then if I have a third point, if I know how to hold this, it'll be flat no matter what. It might not be perfect, but it'll be flat. It'll make a plane. Okay? All good? So then, for this one, I'm going to go ahead and say, in my plane, so for my dots, my points, should they be collinear or scattered? Has to be scattered, then it'll kind of lay right on. That is called non-collinear. So I'm going to call this A, B, and C. And to name this as well, I'm going to go ahead and call it plane ABC. So I can name it with a capital letter italicized. I could name it with the 3 points in the inside. Even if I have multiple points on there, pick any 3 points. 3 is all that we need. So with that said, I want to modify this. Not 4, just 3. So I want you to name 3 points that are coplanar in the drawing to the right. What 3 points are coplanar? Partner up. Talk to your neighbor. There's so many. There's a lot. Let's look at the obvious one. I know everyone looked at this and was like, oh yes, A, B, and C, let's name that 3 different ways. Right? That would be the obvious one. So I'm just going to say A, B, C. You could have said A, B, D, C, D, A, doesn't matter, okay? But here's the idea. Is E, C, and B collinear or non-collinear? So if they're scattered, can I put a plane on top? Yeah, I still can. So thinking outside the box, ECB is going to work out as well. And let's even go further. Now look at the points. D, E, B. Are they collinear or are they scattered? They're scattered. So when I had my marker scattered, was I able to put the flat surface on? Yes. So D, E, B also works out. And I heard some of you guys say there's so many on this. That is true. Okay? What if you chose to completely reverse the letters, like CBA, BCE? It's okay. Okay? All right. Let's try example 2 with the partner. Go.
So, and then you have to count them. That makes sense.
Let's start with the obvious. I heard a lot of you guys go, hey, there's EB has lines on both, EC has lines on both. Those are the obvious ones, right? So I'm gonna write that down first. Just one of them, EB. But you have to put line above it. If you don't, you're telling me it's gonna be not a line, okay? So the one that's not obvious, can I choose CB? Why is that? Because you're right. Why is that?
Because they're connected by the points on like that square on the bottom.
And on the square on the bottom is a plane, and plane does what? It goes on forever. So if the plane goes on forever, that CB is also extending forever, which means we have a line on both ends. So we have CB will be the creative one. But you have to put the line above it to symbolize it is a line because it is a plane that goes on forever. Okay? Now, on a worksheet, I have to stop at some point so I can print it on here, right? But ideally, it's going on forever. I want to look at another creative one. Can I connect A and C? As I connect A and C, the plane goes on forever. Can that be a line as well? For sure. That would be another creative one. AC. Is it AC? Yeah. If you chose the obvious ones for the three of them, that's fine. But I still want to share with you the fact that the symbolic notation above is very powerful. Yes, ma'am. So imagine this plane right here. It is physically expanding as we speak. In that case, that means AC is also getting bigger and bigger and bigger. So therefore, it's got to be a line.
So then all of them are?
Yeah, as long as you have a line above it.
What would it work?
Then all of them are.
They all work.
Okay.
Last question.
What connects all?
So it
Imaginary line. Okay, let's move on to segment versus array. So looking at the segment. Okay, I'm gonna call on somebody. Griffin, give me the difference between a line versus a segment.
Like a line just goes on forever, and a segment's like future.
The segment does what?
It's like stops.
It stops. Very good. So let's draw a segment and stop it with the dot. And we always name them, AB. When you see this in a sentence, you'll see AB or BA. So then Campbell, tell me the difference between a segment versus array.
Stops on one side.
Yes, very good. So it stops on one side, but on the other it continues, but we still want to name that endpoint. So we have CD. The naming on this one is very particular because the arrow that is pointing at must be consistent. Meaning, if I have CD, the arrow should be pointing along the D's. And then if I go the other way around, DC, I need to make sure that is reversed. So I guess array is the only one that's a little bit picky, right? I don't want to worry about that. Let's move on to example number 4. And let's try that with a partner. See if you can draw this image. And then I'll reveal it.
Probably just like
All right, if you think you have the answer, hands up. If you have an opposite ray with a common endpoint, it's going to make a line. It makes a line. And I'm going to give you an example with my drawing. Now, when you make a line, or if you make an array, you can make it diagonal, horizontal, vertical, however you want, correct? But I'm going to be kind of boring and just make it horizontal. So common endpoint has to be T. So if I make this one go to the right, opposite of right is what? Left. What did I make? A line. Maybe I should name this too, right? I don't know, P. You don't have to, but it's appropriate. Okay, let's move on to the next page. Let's box the word postulate and put a big star. Make sure you know how to spell this. Let's start by defining postulate. Postulate is a statement that is accepted as a fact. And I'll give you an example. Andrew, what color is your shirt?
Blue.
Why? Because it is, right? It's called postulate. What color is this? Green. Should I ask why? Postulate. Take it as it is. Okay? Now, in case you struggle with spelling, let's kind of dissect this. Because when we say postulate, do y'all hear C-H-U-L? Postulate, kind of? To avoid that, think of post, you, late. Just kind of section it sometimes. Because spelling it may not be your forte, and that's fine. All right, close your eyes, everybody. Spell it, go. P-O-S-T-U. Boom, did you do it? Okay. If you forget, what do you think of? Post, you, late. All right. The next part, because I don't want to make my handwriting uglier than it already is, I'm going to kind of cheat a little bit. Don't call me that. All right. The first one, as I go over each one of them, I'm going to draw the image. Through any 2 points, there's exactly one line. Abby, are you writing with me? Through any 2 points, there's exactly one line. We're on the second page. And let's see if we can actually make that image with the condition given. Don't write the second part, just the first part. So we want 2 points. When given 2 points, can I make a line through them? That's it. You just got to be fancy with the definition, huh? Okay, only write the second one this time. Through any 3 non-collinear points, there's exactly one plane. And we talked about that with the points, my little markers, right? As long as you have 3 scattered points, by scattered means non-collinear, we can put a plane on top. So don't write the third one yet until we draw the image. So let's make scattered 3 points. 1, 2, 3. Can I set down a plane on that one?
Yes.
Absolutely. How you make the plane, doesn't matter. Make a triangle if you want. Looks like a face. Now let's write the third one. If 2 points lie on a plane, then the line containing them is also in the plane. And you're like, what? So if you're ready to draw two dots, put a plane around it. So 2 dots, put a plane around it, and it's saying, well, then I know I can make a line also. Okay. Then that line is also within the plane. So here's the idea. If your body is in my classroom, is your brain also in my classroom? That's all that it's saying. Okay? Let's partner up for 5 and 6. Go. Let's see if you remember how to write the line and plane.
Name the line. Name the line. Oh, right here. Oh, I don't know, like 2 different ways. HG and then GH.
It's plain I think the P
Yeah, I'm doing my best. It should also be italicized down here too, yes. Just put a swing at the end. All right. The main thing for the line, make sure you draw the line symbol right above it. Don't leave it as GH. All right? For the plane, you have to use the word plane. And how many points do I need at minimum to make a plane? 3. And I only gave you 3 points, right? So we have GHJ, GHJ. Or, I got that fancy little M right here. What do I do if I can't do cursive? Swing. Just swing. That's it. Okay, let's write the first postulate. Wait on the second one. And it says, 2 lines intersect at exactly 1 point. This is kind of like systems of equations last year in Algebra 2 when you were looking for solutions with X and Y. So let's draw line 1. Line 2, that intersects. There's exactly that 1 point, that point right there. Okay, the next one that I can't even draw, I'm going to show you what it looks like, okay? So if you're like, I'm not an artist, I'm not going to draw it, that's okay. So the last postulate states, when 2 planes intersect, they intersect in exactly 1 line. So I'm going to model it with my index card. And then I'll model it with the classroom here. And I kind of show you some samples of student work. Okay, y'all ready? Here I have a plane, correct? And I have another plane. Do we all see that? Everyone looking? Plane, my tiny plane, and I'm gonna make it cross. So when they cross, they're gonna cross at a line. Do we all see the line? Okay, so they cross at a line, correct? Or, if you look at the wall, to my left, this wall, imagine it going forever, okay? Right behind me is another wall. They intersect and create the line, okay? Now, if you're like, I'm an artist, I can draw this, I dare you to, okay? I'm gonna actually show you the one that students kind of sampled. Just be mesmerized. The student goes, I can do it. Pretty good? And then one kid goes, no, not good enough. Let me one up this. And this kid goes, I got shadows. But wait, there's more. Another kid goes, well, that's not that creative. Let's add some grid. I cannot do that. So if you can, it's okay. Now, if you're an artist, try to draw one for a minute. Let's see what it looks like. Even if you're not an artist, try it. If you want to mimic what's on the board, that's fine too. Maybe I should make y'all visualize it. Stop looking. Nope. Nope. Dip. Dip. And then last period, another kid goes, well, I can do that too. I know. They're stressing me out. I can't do it. So whether you are an artist or not, just try and be like, you know what? I'm actually better than I thought. And once you have the drawing, show your neighbor and be like, let's top this.
I made a plane, that's what's up, man.
That's not bad. I can't even do that. Renee's like so focused. I can do it. Yeah, you did it. Put some shadows. It looks good. Emery, let me see. I'll take it. Mine's blank, so yours is way better than me. All right, let's look at one last piece. I'm going to ignore these and move on to the very bottom. There's a typo on this one. So we have two different ones that's got AB is equal to and another AB is equal to. First one should be AB is congruent to. Congruent to has a squiggly with an equal to on the bottom. So here's my question to you. If I give you two pictures that are identical, are they congruent to or are they equivalent to? Pictures. Pictures. I give you a picture. Pictures should be congruent to. But if I give you equal to, is 4 equal to 4? So numbers are equal to. Pictures are congruent to. Keep that in mind. So I'm going to go ahead and say AB will be a value. It'll be a number, specific number. Now that alone doesn't mean anything without an example. So let's all make a rectangle. And someone tell me about the opposite sides of a rectangle. They are? They're parallel, something else. Equal. You guys have a lot of features. Parallel is correct. Equal is kind of what I wanted. So let's go on to the other one. And we want to name this ABCD. And I want to also say, maybe I measured it. So we have BC is 3 centimeters, AB is 4 centimeters. So where else must be 3 centimeters? AD. What about 4 centimeters? DC, okay. So let's see how that relates to the picture versus the value. If, let's say, on a quiz or test, I say AB with the segment above it is congruent to. That means you're looking at a picture. So AB is congruent to what other side? DC, very good. That's exactly what I want. Now, can you say CD? Yes, you can. So then let's look at it numerically. If I give you AB without the segment above it, that means I want, and it says equal to, a value. What's the physical value of AB? 4, that's it. So make sure you see the difference in that. If I give you a squiggly or the congruent to, I want another part that's congruent to. If I give you equal to, I want a number. What is the actual value? Are we good on that?